right, here we're looking at our notes and our learning for section 7.3, and today we're really going to be multiplying and dividing. So on your tab, we're going to check out our learning targets first, because that's where we always want to start. So today, first we're going to learn about simplifying these rational functions and what it means to simplify them and what not to do, which is kind of an important step. And then we're going to look at multiplying and dividing them. Okay? And then we'll get to adding and subtracting in our next lesson. So first we want to look at simplifying these. So you're going to want the handout that says simplifying rational expressions. And one thing you'll notice is we're going to talk a lot about kittens. Don't kill kittens. We'll get there in just a second. So the first step is we want to factor everything, right? So this, if we need to brush up on our factoring skills, this would be the time to do it. So factor everything. Factor the numerators, factor the denominators, factor everything. Then step 2 to simplifying is I cancel factors, not terms. If it's everything's being multiplied together, I can deal with factors. I cannot cancel out terms. So if two factors are close to canceling out, but they're just off a little bit, you can factor out a -1, and oftentimes that'll get it to be where you can factor out that factor. You can cancel out that factor. So then we got to double check and make sure everything is completely simplified. So here's what I mean by we cannot cancel out terms. So in this numerator, I say I have x squared plus 2x plus 1 divided by x squared plus 3. These would be terms in my trinomial and my binomial. I cannot cancel them out. That is what we're talking about. This is not an accurate thing. So every time you do this, a kitten dies. So make sure you're careful with your simplifying. Okay, so now let's look at multiplying some rational expressions. So again, step 1, factor everything. We're going to say this over and over and over and over again. We want to factor everything. So if there's multiple terms, definitely draw your parentheses around everything. Then, just like when I'm multiplying fractions, I multiply across the top. So I multiply the numerators, and then I multiply the denominators, and then I simplify. So here's our example. So I've got 3x minus 3x squared over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. So step 1 is I factor everything. So in this first numerator, I know I can factor out a 3x, so I'm left with 1 minus x. Factoring out this denominator, I end up with x minus 1 times x plus 5. Factoring this second kind of rational expression, the numerator, I end up with x plus 5 times x minus 4. And my 3x, I can't actually do anything. So I notice that all of my other factors have the x first, and the x is positive. So I want to try that with this one, because I just have a 1 minus x. So I'm going to go ahead and factor out that -1 so that x is first and positive. So here I have that factored out. The next thing I do is I just multiply straight across. And before I actually do the multiplication, I'm going to simplify first. So once I multiply, I go ahead and I cancel out the factors. And I can cancel these because they're factors and not terms that are the same in the numerator and the denominator. So I see I have a 3x in both the numerator and the denominator. I see I have an x minus 1 in both the numerator and the denominator. I have an x plus 5 in the numerator and the denominator. So then I've gone ahead and canceled all those out. So what I'm left with is that -1 and this x minus 4 in the numerator. And nothing's left in the denominator. Okay? So to fully simplify that, I end up with a -x plus 4. But there are a couple of things that x cannot be. So then I have to ask myself, okay, so what is going to make my denominator 0 at any point in this? And that's where these values come into play. So x cannot equal 1, x cannot equal a -5, and x cannot equal 0. So I have to put a couple of limits on what this actually can be, and I come up with those of what's going to make my denominator 0. Okay, so let's go ahead and divide. And again, we're going to follow kind of very similar steps. By step 1, factoring everything. Factor all the numerators, factor all the denominators, factor it all. And put parentheses around them. Then, just like I did when I was dividing just plain old simple fractions, I keep the first expression the same. I change my division to multiplication. I take the reciprocal, so I flip the second fraction, and then I follow my multiplication steps. So here's our example. Is I have 7x divided by 2x minus 10 divided by x squared minus 6 x over x squared minus 11x plus 30. So my first step is I factor everything. This first numerator, it can't be factored at all. I know I can factor out a 2 from this denominator. I can factor out an x from this numerator, and this denominator can be fully factored. So step 3, right, was I keep my first expression the same. I change it to multiplication, and I take the reciprocal, so I flip this fraction, the second one. Okay, so now I'm going to follow my steps for multiplication. So I just multiply straight across the top, and I multiply straight across the bottom, and then I simplify. So here I have and again, I can simplify and cross these out because these are factors, they're not terms, right? I'm multiplying together, so that means I can cancel things out. So I see I have an x in both the numerator and the denominator, so those can cancel. I have an x minus 5 in both places, and I have an x minus 6 in both places, so those all cancel out. So what I'm left with in the numerator was a 7, and what I was left with in the denominator is a 2. Again, I have to limit my x values. I have to put some constraints on there because we're dealing with rational expressions, and we can't ever be dividing by 0. So I have to figure out what is going to make this denominator 0, and so those are my x cannot equal 0, x cannot equal 5, and x cannot equal 6. Okay, so here we've worked through an example of multiplying and an example of dividing, and we've been able to simplify them both. The big thing I want you to remember is do not cancel out terms. We cannot cancel out terms like this. We have to cancel out entire factors that are kind of in our parentheses together. Okay, so if you look back at your learning targets, remember that our goal today was to learn how to simplify rational expressions and then actually multiply and divide them. So now that we've gone through both of those, go ahead and start working on those practice problems and let me know whenever you get stuck.